Limiting reactant chemical quantities. So we're going to be considering the reaction shown here. 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of water vapor. So we're going to start just by looking at these 2 containers. We have our reagents, also called reactants, and then we have our products. So how many molecules of H2 are in this chemical reagent container? So we can count. We've got 1, 2, 3, 4. Oxygen, we have 3. How many water molecules are produced? We're going to produce 4. And you'll notice that we have some unreacted oxygen that is left over. And that's because we used up all of the hydrogen and ran out of oxygen. So if we react 100 grams of O2 and 50 grams of H2 in a container, how many moles of water could I make from each? So we're going to say if we start with 100 grams of oxygen, how many moles of water can we make? So we have our balanced chemical equation. If we start with 100 grams of O2 over 1, we're going to cancel out grams of O2 and convert that into moles using the molar mass. And then we want to change mole of O2 into mole of H2O. So 1 mole of oxygen is going to weigh 32 grams. So oxygen weighs 16 grams per mole. So O2 is going to weigh 32 grams. And my mole ratio here is 2 to 1. So that 100 grams of oxygen can make 6¼ moles of water. What if we start with our 50 grams of H2? So similar calculation to above, we're going to change my grams of H2 into moles of H2 using my molar mass. And then I want to change from moles of H2 to moles of H2O. So the molar mass of hydrogen is going to be 2 grams per mole. And my ratio here is 2 to 2. So if I use all 50 grams of H2, I should be able to make 25 moles of water. Now, one thing that we want to look at, we might assume, since 50 is less than 100, that we have less hydrogen than oxygen. And that's not true, because 100 grams of oxygen, keep in mind that each mole weighs about 32 grams. So this is only about 3.1 moles of oxygen. Whereas 50 grams of hydrogen, because hydrogen has a much lighter molar mass, is 25 moles of hydrogen. So based on our answers, are we going to make, how many moles are we going to make? So if we start with that 100 grams of O2 and that 50 grams of H2, we can only make about 6¼ moles of water. Then we run out of O2 and the reaction stops. So the limiting reactant in this scenario is going to be oxygen. So now we want to calculate the theoretical yield of water in grams. So we already know that the most we can make is 6¼ moles. We want to figure out how many grams of water that corresponds to. So 1 mole of water weighs 18 grams. So I'm just going to multiply 6.25 times 18, and this gives me 112.5 grams of water. So this is my theoretical yield. It's the maximum amount of water that I can make from these starting ingredients, assuming that everything goes perfectly. Okay, so our next question here. What mass of nitrogen dioxide can be made from 30 grams of NO and 30 grams of NO2? So we're going to do 2 calculations here. I'm going to start with grams of NO, and I want to convert that into moles. Then I'm going to use a mole ratio to get moles of NO2. And then since I want my final answer as grams, as mass of nitrogen dioxide, I'm going to convert grams to moles, or excuse me, moles to grams using my molar mass. So the molar mass of NO is about 30 grams. My mole ratio here is 2 to 2. and 1 mole of NO2 weighs about 46 grams. So I'm going to do almost the exact same calculation, but this time I'm going to start with my 30 grams of O2, change that to moles, use a mole ratio to get moles of NO2, and then use my molar mass to get grams of NO2. So my molar mass for O2 is about 32 grams. My mole ratio here is 2 to 1, and my molar mass of NO2 is still 46.01. So the amount of nitrogen dioxide that I can make is 45.99. I can't make 86.25 because after I make 45.99, I run out of NO and my reaction stops. So the amount of NO2 that can be produced depends on the limiting reactant, because once that limiting reactant is gone, it can no longer be used to make NO2. We've used it all up. So for the next question here, we're looking at acetylene gas. This is used in high temperature torches to do things like welding. So we want to write a chemical equation for the reaction of acetylene with hydrogen gas to form ethane. So acetylene is C2H2, and this is reacting with hydrogen gas, which is H2. Remember that hydrogen is one of our diatomic elements. And we're going to produce C2H6. Now, when we write this chemical reaction, this is really easy because all of these are molecular or covalent compounds. So there's no charges or ions or anything of that nature to keep track of. So we just need to balance this equation. If I put a 2 in front of H2, that'll give me 6 H's on each side and 2 carbons on each side. So we want to know how many grams of ethane can I make if I start with 30.3 grams of acetylene and 4.14 grams of H2. Now, don't assume because we have less grams of H2 that that is going to be my limiting reactant. We really have to compare the amount of moles of each of these compounds. So I'm going to do 2 calculations. In one, I'm going to start out with my grams of C2H2. Convert that into moles of C2H2 using molar mass. I'm going to use a mole ratio to get moles of C2H6. And since this question asks for grams, I'll change moles of C2H6 into grams. So 1 mole of C2H2 is going to be about 28 grams. My mole ratio here is 1 to 1. And the molar mass of C2H6 is about 30 grams. So I'm going to do a very similar calculation, but this time I'm starting with my grams of H2. So I'm going to convert grams of H2 into moles using my molar mass, about 2 grams per mole. This time the mole ratio is 1 to 2, and the molar mass of the C2H6 is still around 30 grams. So the one that I can make 30.81 grams. After I make 30.81 grams, I'm going to run out of hydrogen. So hydrogen was the limiting reactant in this case. I can't make 34.99 because I'm going to run out of hydrogen before I can use up all of that acetylene gas. So how does this help us figure out our limiting reactant? So anytime you do a limiting reactant calculation, you're going to pick a product and see how much of that product you can make with your starting ingredients. And whichever one makes less is going to be your limiting reactant. So whichever makes less product, in this case, we only have one product to choose from, that's how we know that hydrogen is my limiting reactant. So when you're doing this calculation, we just have to be careful to make sure that our units are all working out and that we are comparing the amount of product. Sometimes you have more than one product, in which case you just want to be clever. If I had more than one product, but the question is asking about the first one, then I would pick that to do my calculation.